So what I'm going to try to do today is go over this tooling dough, and it's a little bit different concept. Normally on a small mold you don't need the tooling dough. I'm going to talk about some different uses for it. Obviously you got the use of tooling dough in a composite tool, but you can also use it for other things, and I'm going to experiment with some of the different uses it might be applied. So I'm going to go through here, make sure I'm streaming. I'm not sure if it's going through or not. So we'll see. I'll do a little GoPro here. Basically this will be for the edits. So the first thing I need to do is get some epoxy in this mold. Now, yesterday I actually took the fiberglass on top of the surface coat, and I've got that in there. You can see over here on the mold. So right here there's roughly 3 layers of glass. There's a couple layers of real fine 3-ounce, and then I got a couple layers of it's probably about 8 or 9 ounces. It's like boat cloth in there. So we'll see how that works. One of the things to remember when you do this cloth, when you do the tooling dough, you start out with the surface coat, your glass, your dough, and your glass. You want the glass to be the same on each side of the set. Want your glass to be the same on each side of the sandwich core. So if there's a little disparity, you could get into some warp problems. So let's get some resin mixed up here. This is HTR 250. I'm going to go with the 106.3. I'm just guessing. I'm thinking probably 20 grams of resin will probably be able to coat that tool. %, 2.4, be 4.8. So we're going to add 4.8 to that. things I need to do. Transfer some of this hardener in another container I got. So this coat of resin in this mold basically just helps the surface or the tooling dough adhere to the mold. It gives the tooling dough a little something to bite to. Try to spread this as thin as I can. Trying to get away from having to mix up more. So you don't want to flood it with resin, you just want to get it to where it's wet. That'll allow the tooling dough to bite a little bit. I might be a little bit past the B stage here. One of the things I did do when I was doing the surface coat, I actually took some DTO81, sprinkled it on top to give me a little bite. See if that would help any. If it goes a little past the B stage, which is the rubbery stage, you get into the situation where you lose your chemical bond. Now, this just being the hobby stuff, I wouldn't. You try to do the best you can, but you got to remember it's still a hobby. You get a little bit more leeway. The other thing that makes a difference on these molds is how you're going to use them. If you're going to take a mold and you're going to do a mold that has to be used in an autoclave, or you're making a mold that's room temp cure, it's two different things. And I don't know, you probably can't see from the camera, but some of this glass here bubbled up a little bit. And that would be a problem in an autoclave. You'd want to debulk all this. Get all the voids out of it. because of the extreme crushing pressure. But a room temp cure mold is a little bit different. Now this might go into a warming box, but it's not going to see a lot of temperature, even though it's a high temp mold. And also the construction of this mold would change if I was going to vacuum bag it in an autoclave. So I pretty much got this resin spread around, I think. Might as well use up all the resin in this cup. So if there's a little air bubble there, just force some of this resin down in it. No big deal. See if I can poke a hole in there and get some of the resin down in that glass there. Now, moving on to the tooling dough, there's one thing you really need to do if you buy this stuff from Resin Services. I bought these 5-gallon pails without an opener. The way these pails are constructed, you're going to need an opener. Hey, if anybody's watching, which I'm not sure there are, give me a thumbs up or an okay. I want to see if I'm actually streaming this thing. I'm not sure if I am or not. So it's real important when you stick gloves into a tooling dough that you don't contaminate it with a hardener from something else. Pull these off really good. I don't think I got anything on them, but okay, now the opener I was talking about with the tooling dough, these pails, it's almost mandatory you've got one of these tools to open the 5-gallon pail. These two here have different settings. This one's a little bit wider, this one's narrower. For the pails that I've got over here, the plastic one here, this one works better than this. They both work, but this red plastic is the one that worked the best. So here's what I'm going to mix up. Now this tooling dough is part A and B, of course, and 25% by weight, and it's got to be mixed quite a bit. I mean, it's not a automatic thing. I mean, you got to work it. It's It's obviously dough. You'll see here in a second. So this is going to be the bucket I'll mix it in. Turn my scale on here. And I'll just go with ounces. So right now I'm looking at 2.2 ounces. And then I'm going to go over here and tare it, so I'll zero the scale with that on it. So remember that's 2.2 if you lose track and you got to actually refigure it. So this is the consistency of the dough. You see it's not a solid, it's sort of gooey. Not gooey, but sort of fluffy. You can tell it's got a lot of micro balloons in it. And I'll mix up multiple batches of this stuff. I think it takes more than a bucket of this. And another thing I'll do before I finish here, I'll figure out the density of this. Now, I've already used my left hand to grab the dough. Use your right hand to do the curing part of it, the 25%. Okay, so I got 14.8 ounces. Let's just make it 15 ounces. Let's see how close I can get. That's 15.4. See if I can get 16. 15.8. 16.2, that's all right. I'll be here forever trying to. 16, okay, there's 16. So I'm going to add 25% by weight. So I got 16 plus 25% would be 20. So I need to get 20 ounces into this bucket. 16, 17, so there's 17.8, 18.4, 19, 6, there's 20. Now, so the best way for me to describe this stuff. Okay, thanks, Will. I wasn't sure if I was getting through or not. The best way to describe this stuff is crumbly. And one of the things I'd like to do with this dough, I'll do some here outside the mold. I'd like to actually find out sort of hard to keep it together at first. I want to find out the density of this stuff, how many pounds per cubic foot. I know it's not 4-pound balsa, but we'll find out. And the reason I want to find out the density is so if I ever use this as a core material, then I can go through there and make different parts out of it. Now it's got a color. I don't know if you can pick it up on the camera, but the what is it? The big part, I'll call it the A part, is the gray, and then the B, I guess the carrying part of it, it's got an ammonia smell. That is the sort of beige. And as you're rolling this stuff together, you can tell it's not mixed. You can see the disparity, and it's got a marbly look to it. And the more you work this stuff, the gooier it gets to a point. But it'll start to stick together better. So, Will, if you're still watching, I tried to find a link on that Pampa site. I wasn't able to find it. We'll work on it. I'm not sure. I think it would be good, Will, if I missed the meeting at the Nats, you know, the Pampa executive meeting or whatever. I think it would be good if everybody showed up prepared that's on this communication committee or has insight, that we could sit there with all the information in front of us and go through it. It gets pretty complicated when you start adding a lot of variables. So you can tell, or I hope you can see the marbling go away. Now, one of the things with this tooling dough, you can make jigs and fixtures out of this stuff. So see how it holds its shape? So if you wanted to make something, a fixture to hold anything, you know, you could use this stuff. The other thing I was wanting to do with it is if you hold it in your hand long enough, or you work it, basically, I've done this before with DTO81, basically you could almost custom make your handle, like handle grips. You know, there's a lot of things it could be used for if you use your imagination. So now that it's starting to become mixed, and I'm starting to get a chemical reaction between the two, you can see how it's getting stickier. And I just peel it out and I get a good look at it to make sure that, you know, it's all mixed. So let's just, well, this is, what did I say this was? We'll zero it. I think it's 20 ounces. Yeah, showing 19.4 now. 8. I probably lost a fraction on my crumbs. Okay. Okay, let me pivot this camera over here. I got a little height gauge on this thing. I'm going to try to actually get this stuff between 1/4 and 3/8. I laid up the first half, and it was one of these things where I think I overdid it a little bit. So it's just a messy process here. So I'm going to come in here and try to keep it relatively thin. Like I said, around a 1/4 to 3/8. Now another possibility is to actually take this stuff with a rolling pin or whatever and roll it out between 2 pieces of music wire laying parallel, and you could almost sandwich it between fiberglass or plastic when you roll it. So once you'd roll out the precise thickness, then you would actually be able to bring it over here and just lay it into this mold. So we'll see when I get these 2 halves separated on this fuselage mold. I'm going to find out between this first half and second half with different thicknesses what I can get away with. And I'm almost positive I can get away with this 1/4 inch. The first half is like unbelievably, it's rigid. I don't know if you watch some of these guys that do this stuff. They actually have molds that are somewhat flexible to actually get their part out. So I'm going to go around the perimeter here as much as I can. It takes a lot of pressure too. I mean, don't be afraid to push hard on it. Mold it out. The more I go through it and the more I work this down, I try to smooth it out as I go, the smoother I want to get it. So if you're wondering, it's like, why would you go through the trouble of dough? The bigger the mold gets, the heavier and more costly it gets. And what the tooling dough does, it gives you a lot of rigidity with not much weight. So the tooling dough creates a sandwich to give you your strength without the weight. So you're spending money on the dough, but you're saving money on the fiberglass and resin. So it's just one of those things you have to figure out, I guess, you know, how far you want to go. So this tooling dough, it's made to post cure. So I think I got to look at the spec sheet, but I think you can post cure this up to around 300 or 400 degrees. And I'm not sure, here's the other thing. When I worked at the composite shop doing their woodworking stuff, all they did was autoclave parts. And I wasn't really sure if they ever used any of this tooling dough. And maybe it's something on the autoclave level that's not really feasible because of the voids you can pick up. I'm not really sure. But I think for this application here, it's worthwhile. Plus, you can build up a tool really quick. You could take 2 layers of glass on top of your surface coat, let it kick off into the B stage, and then come back with your dough and then lay 2 layers of cloth over the top of that. And I think you could probably build up a small tool in one day. So you can see on the side, see it didn't really want to stick too well. And that's where I don't have any resin. Down here on the tool itself, you know, I've got enough resin to where this tooling dough is mating well with the tool itself, the fiberglass. You can see right here where it's sticking really good. You know, when I pulled up that blob. And don't be afraid to smear it a little bit and work it in. You know, especially initially right there at the attachment point, adhesion point. So I'm going to make up, see, I got 20 grams or 20 ounces here. I think another 20 will finish it, maybe 24. So the idea behind this whole crazy thing I'm going through here is to eventually make the tooling for a control line aerobatic airplane. And there might be variations of what I do with how I do the wing versus a fuse and different things. But that's the end goal. I want a composite airplane. And I want to try to improve on what's already out there. Whether I can do it or not, I don't know. I think we're down to the point where, as far as the sandwich core, I think it's glass, foam core, glass. I think carbon probably wasn't viable because of the weight, maybe. At least with the normal vacuum bag. Maybe you could do it on an autoclave with spread toe, I don't know. So there's a lot of ifs and or buts, but we'll see. Now, the more you work this dough, like I said, the gooier it gets, but it'll get to the point where it starts to B stage on you, and it'll start to become where you can compact it without it flaking off. It becomes a little bit more homogeneous the more you pack it and tap it, because you'll see like little voids, you know, where it comes together. And start to work that out. So by tapping it, it raises the gumminess to the surface, and you're able to get a really good smooth surface on it. And what you want to do when it comes down to glassing over the top of this, you want to get it smooth enough to where there's no puddles. And you want the glass to lay really flat on it. You know, the other option before a full-size airplane, and something I thought about for a long time, is make another fuselage plug for Billy's P-47. And I understand, you know, there's a lot of drag on the nose and, you know, certain things with the design. But I thought it'd be neat if somebody could actually buy a competitive fuselage. I mean, something nice where it's light and rigid. It checks all the boxes. Well, all they have to do is put a wing and a stab on it. Now, I'm not so sure, you know, how it would all work out, whether it be take apart or what, but at least you'd be able to build, you know, a traditional P47 that Billy had. And, you know, without constructing a fuselage, getting one that's competitive. That's just an idea. So we'll see. So that's pretty close right there. Another thing I've done with DTO81, once it starts curing up, I'll take some resin and I'll mix into it, and I'll make it into like a slurry. So what I'll do is actually rub it back and forth, the slurry, and it sort of brings it all together. You know, makes it really super flat and tight. So let's see. All right, Will, thanks for commenting and let me know. What I've got to do now is get rid of these gloves and leave my plastic here, because I'm going to make another batch, and I'll jump off here because you don't need to see the second half, which is the same thing I just did. And I'll probably come back, you know, for a video that actually shows me doing the opening of the fuselage and everything. Also, I got a second camera going where I'm editing some stuff on YouTube, for YouTube, off of a GoPro. So not only is it a live stream, it's an actual recording. So that's about what I got right now for the live stream. So I'll turn this off, and when I get to another stage, it's a little bit more interesting. Probably test samples. I'm going to roll some of this out in some different thicknesses because I want to know the density of this stuff. And the reason being is the foam that I did on these test samples, it came out okay. But the problem with these test samples, it left me a perfect shiny surface when I did this on the glass. The problem was how easy you could crush it. You know, you could just dent it really easy with your finger. So what I'm looking for is this weight of glass, which would be about an ounce, a little over an ounce, with something that won't crush at 4 to 6 pounds per cubic foot. And I'm thinking if I could do tooling dough, specially made or with an addition of microballoons in it, to where when I put the two mold halves together, I could squish it. It wouldn't expand, but I could squish it somehow where it would become my core material. So I've been racking my brains over that. So I'm sure there's stuff out there that'll do it. I got some people with some feelers out looking for me. But we'll see. It's sort of unique to what we're doing. It's not really cut and dried. There's a lot of ifs, ands, or buts. And when you go from something that expands to something you can press, it changes things a little bit. So okay, I'm going to click off of this thing, come over here to this crazy computer, see if I can find a button to get out of here. So thanks, Will, for doing the chat. Let me know. So, till next time, I'll catch you. Thanks for watching.